One is about a pentagonal pyramid. So this is a pentagonal pyramid. Looks like this in the front view and looks like this in the top view. Fine. Okay, so this is the top view, which is a pentagon, and these edges are the slant edges joining the corners of the base to the apex. Okay, these are the base edges. This is the base corner being joined to the apex by the slant edge, and these triangular faces are the slant faces of the pyramid, as you can see here. Okay, so let's go back to the front view. So this front view will look like this, and the corresponding top view will look like this. It has having one base edge perpendicular to VP. Now let's say the question says that it is resting, the solid pyramid, pentagonal pyramid is resting on one of its base edges on HP, and its axis is inclined at certain inclination to HP. So let's give that inclination in the forward direction always, and put this on HP. Okay, this on HP. So how will the top view look like? It will look like this. Okay, and the line view will be like this. So only this edge will be hidden in this projection. Let me show you how that happens. You have to see this in 3 dimensions to be able to understand how this is working. Say this. So this is the pyramid having its one of its base edges on HP. Okay, this is the side view, as we can see, and these are the two slant edges which we can see from the top. Okay, these are the two slant edges which we can see from the top, and this is how the base edge looks like from the side. Rotate it a little more. Yeah, now you can see, right? So this is the pentagonal base edge having base itself having one of the base edges on HP. And this is the, we come back to the front view. So this is the front view which we are seeing, and this is the top view which we are seeing. Okay, now you can imagine how it looks like. Back to the line view. That's why I'm saying this is the base edge on HP which will be hidden. Now let's say the axis which in front view is inclined to HP at certain angle. That axis in top view is right now parallel to VP. Let's say it is inclined at some inclination beta to VP. Let us give that inclination as we have done in previous questions. Let's move the apex towards the observer in this case, something like this. So this is a moved at 45 degrees too with respect to VP. So this is the TVL somewhere here, from here to here. This is the TVL of the axis moved at 45 degrees inclination beta with respect to VP. Now let's see how will be its front view. This is its front view. To help us imagine the hidden edges, this is the solid view. Okay, so solid projection shows this is the edge on HP, this is the rest of the base edges, and there are two more edges here. 1, 2, 3 are visible. There are two more edges here which are not visible. Okay, we can see that in the line view. So we are not able to see these two edges which are behind the view, plus this slant edge which is also behind the view. Fine, there are supposed to be 5 slant edges, 4 of which are visible. You can see 1, 2, 3, 4 are visible. One slant edge is not visible here, and 1, 2, 3 base edges are visible. So 2 base edges are not visible here. You can see this. This is the situation of the pentagonal pyramid. Okay, so the front view is from this side, and that's why from the front view the base is not visible. because we turned it that way. Okay, this is completely the back view, front view is from that side. So the base is not visible, and this edge, this slant edge is not visible. Fine. So we go back to the front view and the top view. This was the top view. We had turned the apex towards the observer and base away from the observer. That's why the front view is appearing like this. Okay. So this is how it is appearing. Let me move it from the base side also so that you can imagine it better. Yeah, something like this. Front. This is the front. It is now turned towards the front, and this is the top that we were seeing. This was the top. This is the front. Thank you.